Okay. Are you able to see the PPT? Sriram, able to see the PPT?
Yes, ma'am. Yes, ma'am.
Okay, fine. So can someone tell me where did we stop in yesterday's class? Hmm? What topic were we discussing in yesterday's class? Hmm? Nobody
The
remember?
name Bayesian classification algorithm.
Yeah. So we had started. I mean, we were discussing about a second classification technique, Naive Bayesian classification. I told you about the Bayes theorem, then how it is being used in Naive Bayesian classification. Then I gave you the algorithm for it, how predictions can, and then we discussed how predictions can be done with it. Then I showed you one problem yesterday, which I asked you to work out using Naive Bayesian classification. Okay, so anybody tried working out that problem? Anybody tried? I'm not asking whether you completed or not. Just have you tried working out that problem? Hmm? Akshata has tried working out the problem. Hmm?
Yes, ma'am.
Did you try working out the problem what I showed you yesterday? Hmm?
Yes, ma'am.
Hmm. Okay, so today I'm not going to work out the problem today. That will take it up in tomorrow's special class. I'll be conducting a special class tomorrow from 1 o'clock. So during that special class time, I'll work out the problem. Okay, anyway, I have told you what it is all about and how do we go ahead with the problem. So today I'm going to start with the next classification technique. Okay, so that problem we will be doing it in tomorrow's class. Okay, fine. So any idea what is the next classification technique that we are supposed to discuss? Hmm? So we have discussed decision tree induction and the three decision tree induction algorithms. Then the base classification methods. Okay, so today we are going to discuss about rule based classification. Rule based classification or rule based classifiers, or in fact rule based learning. Okay, so uh, like how, I mean, here your models, your learned models, that will be represented as a set of if then rules. Okay, so if then rules. Okay, so okay, before we come to that, to bifurcation of the classification rules. Okay, so there are two ways in which you can generate the classification rules. The first one is what we call it as the direct method. Second one is what we call it as the indirect method. Okay, so direct method means you extract the rules directly from the data. Okay, so examples of the direct classification algorithm is you have all these sequential covering algorithms and 1R algorithm. So as a part of your syllabus, we'll be discussing this, the sequential covering algorithm. Okay, so then you have this indirect method, indirect method which extracts rules from other classification models. Okay, so you have a decision tree about which you have already learned. Okay, so and you have techniques like genetic algorithm which fall into the category of the so-called indirect classification models. Okay, so these are the two ways by which you can generate the classification rules. Okay, okay, right. So now let's see how, what is this classification rule or how does it look like. Okay, so how the model can be represented as a set of you can see here if then rules. Okay, so actually this type of learning, that is rule based classification or rule based learning, it is more suitable when you're analyzing data that contains both numerical attributes as well as qualitative attributes. Okay, so describing something, not just numerical values. Okay, Okay, when you have data with a mixture of these, so you can go for rule-based classification. Okay, and again, this rule mining or learning from rules, it's much more easier for human beings to understand and interpret. Okay, when it is rule-based classification. Okay, so yeah, so you can see here how the general format for it. If condition, then conclusion. If condition, then conclusion. Okay, so this is the association rule. Okay, so the association rules are nothing but simple if then statements. Okay, so they basically show the probability of relationship between the data items in the data set. Okay, so it takes this form: if condition, then conclusion. Okay, so you can split it into two parts. Okay, split it into two parts, where the first part is what is called your antecedent part. This is called the antecedent part. So that is the if part. If part is what is called the antecedent part. And then part, then part is what is called your consequent part. Okay, then part is the consequent part. Okay, so basically this antecedent is also called precondition. Precondition. Okay, it's basically the you can say some test condition. So it can have one or more attributes. If it is more than one attribute, so they will be, you can say they'll be joined by an and. You can see the example here. And okay, a conjunction of attribute value pair, and you can. Okay, and then it will be evaluated as a boolean, that is true or false for each instance of the data set. Okay, so that's what is your antecedent. Antecedent is nothing but your antecedent or precondition, basically your test condition. Test condition. Okay, so the various attribute value pairs. So this you can see here: attribute value age is equal to youth. It is being, and student is equal to yes. This is the attribute age, the value is youth, attribute is student, value is yes. So they are connected by and there is conjunction. Conjunction operation of attribute value pair. Okay, then it's evaluated to true or false, that is yes or no, for each instance of the data set. Okay, so then you have the second part, consequence. Consequence is nothing but the consequent, not consequence, sorry, consequent. Consequent is nothing but the conclusion. Conclusion, or you can call it as class prediction. Class prediction. Okay, so you can represent the knowledge in the form of if then rules. Okay, if age is equal to youth and student is equal to yes, then buys computer is equal to yes. Which means if he's a youth and a student, then he will buy a computer. Okay, so you can write it with these symbols too. You can also write this rule is stated as R1. Okay, R1, age equal to youth, and you can use the logical connectives also. And student is equal to yes, buys computer is equal to yes. Okay, so you're basically representing the knowledge in the form of what is called your if then rules. Okay, I hope it's clear. Okay, so if the condition holds true for a given tuple, then the antecedent is satisfied. Okay, so tuple in the sense your record. Rows, records, tuples, they're all synonymous terms. Maybe you'll become more familiar with those terminologies when you learn DBMS. Have you all learned DBMS?
Ma'am.
No.
It's a subject in the upcoming semester.
Okay, fine. Okay, right. So okay, so that's what your tuple is nothing but record or row. Records. Generally, the data is being
But we had this
visualized.
in SQL, ma'am.
You had in
I had learned this in SQL.
SQL. Okay, you by yourself. I think it was not a subject for you, right?
In the higher secondary, most of them had SQL, I guess. Ma'am.
Oh, okay, fine, fine, fine. Many of the students also have studied CBSE also would have studied that DBMS, RDBMS table relation, how it is being put.
Yes, ma'am.
Okay,
Yes, ma'am.
fine. Right, right. Anyway, it's just for you to understand how it will be, data would be stored. Okay, so that's regarding the association rules, how it takes the form if and then condition, if condition, then conclusion with antecedent or precondition and consequent or class prediction. Okay, so now coming to the rule evaluation metrics, metrics, the unit of measurement with which the rules would be evaluated. Okay, so generally it's being assessed by two parameters. One is called the coverage, and second one is what is called the accuracy. Accuracy, coverage and accuracy. Okay, so this hash stands for the number. So number of tuples covered by R. Covered by R. Okay, that is covered by, that's the coverage. They are the correctness, the number of tuples correctly classified by R. Okay, you can see here coverage is equal to n covers divided by the total data set. In the sense, coverage means how many number of instances are satisfying the antecedent of the rule. Antecedent of the rule, that is coverage, divided by the total number of instances, that is this D, total number of instances in that data set. That's what is basically the coverage. Okay, so n covers divided by, it is written D. D is a training data set, so that's what is coverage. Okay, how many instances is satisfying, I mean, how many instances is satisfying the antecedent of the rule, left hand side of the rule, or if part of the rule, okay, divided by the total number of instances. That's what is the coverage. And then you have the accuracy, n correct divided by n covers. What it means is, uh, yeah, n correct is the number of tuples correctly classified by R. In the sense, how many number of instances satisfy both your antecedent and the consequent of that particular rule, divided by the total number of instances that satisfy the antecedent part. Okay, so that's what you mean by the accuracy. Okay, accuracy of a rule. Okay, so this is antecedent. Yeah, this is the correctness, accuracy part. Correctness is nothing but your accuracy. This is all about your coverage. Okay, so that's what the rule evaluation metrics tells about you. Okay, so now how do we go for rule execution? Okay, rule execution. Okay, so this rule based classification models. Okay, it is not just one rule that they'll be generating. Okay, so when they generate more than one rule, definitely there could be conflicts. Okay, and you will have to impose some order in as far as the execution of rules is concerned. Okay, so that is in case there are more than one rule to classify a particular test instance. Okay, so conflict resolution strategies will have to be incorporated or executed. Okay, so in case on the other hand, if there is no rule to classify a test instance, of course then the default class would be used. Okay, so we are not concerned about that, the case where there is no rule to classify a test instance and default class to be used. We are concerned about how do we take care when you have more than one rules. Okay, so in which case you will have to go for some conflict resolution strategy. So there are three mentioned out here. So one is basically the size ordering, second one is the class based ordering, and the third one is what is called the decision list or the rule based ordering. Okay, so you can see here size ordering. Okay, so size ordering in the sense assign the highest priority to the triggering rules that has the toughest requirement. Okay, with the most attribute test. Size ordering. Okay, so in the sense it involves assigning priority based on the antecedent size. Okay, assigning the priority based on the one which has the toughest requirement, in the sense which has the based on the antecedents size. Okay, so you're involved, I mean, assigning some sort of priority. So that's what is your size ordering all about. Okay, second one is all about class based ordering. Okay, so decreasing order of prevalence, or misclassification cost per class. Okay, so in the sense here, you're ordering the rules based on the uh, most frequent class. That will be appearing first. Then you move to the next frequent class. So some sort of ordering for the class. That's class based ordering. Class based ordering. Okay, so that's what is the second one. Okay, so ordering the rules based on like the most frequent target class coming first, then the next frequent, and so on. So some sort of ordering is being done. Okay, the next is rule based ordering. Okay, so this is actually considered to be the most popular among the three. The one which we are doing right now. This rule based ordering. Okay, so you order the rules in the form of some decision list, or it can be even be a priority list. Okay, a priority list based on the uh, quality of the rule. Okay, quality of the rule in the sense based on, we just discussed about two metrics. What were the two metrics that we discussed? One was coverage and one was accuracy. Okay, so based on that, you I mean prepare a decision list or a priority list according to some measure of rule quality, or by expert in the sense by expert knowledge. Okay, so now people who are domain experts in the relevant field can decide the ordering and can prepare the decision list or the priority list. Okay, so that's regarding the rule execution strategies. Okay, how do we take care of conflicts? You can either go for a size ordering or a class based ordering, or you can go for a rule based ordering, a decision list. Okay, so now coming to rule extraction from a decision tree. Okay, so this comes under direct method or indirect method. Direct method, did we discuss about direct and indirect method? So in this, decision tree comes where? Indirect method, right? So this one, it's a decision tree, which extracts rules from other classification models. So decision tree and genetic algorithm belongs to this category. Okay, so we will be first discussing about an indirect method, and then about a sequential covering algorithm which falls under direct method. Okay, so rule extraction from a decision tree. Okay, you can see here, decision trees are very familiar to you right now. Okay, so this how this if then rules can be generated from decision trees. Okay, so you have already learned about the decision tree construction using popular algorithms, either by using your ID5, or by using C4.5, or by CART, and then you choose the best attribute as a splitting criterion. All those aspects we have learned. Okay, so once this decision tree is being constructed, okay, all each branch, starting from the root, this is the root, and till the leaf, so that actually can be translated into a rule. Okay, so each of these branches can be made into a rule. You can see, if age less than 30 is considered as young, then middle age is considered to be 31 to 40, then this is being considered as old. This is young, this is middle aged, and this is old. Okay, so you can see each of these branches, starting from the root to the leaf, it's being translated as a rule. For example, you can see here, if age is young, and student is no, then Bayes computer is no. Which is that rule? This one, age is young and if not a student, then will not buy a computer. Or age is young and student is yes. This is the next branch. Next branch. So then Bayes computer is equal to yes. Or age is middle aged. This one, age is middle aged, then Bayes computer is yes. Okay, so this is how rules are being extracted from this particular decision tree. Okay, so how rules are being extracted. Or this one, Okay, if age is old, greater than 40 is considered as old in this particular scenario. Okay, so the age is old and credit rating is excellent. That is this part. Credit rating is excellent. Then again, Bayes computer is no. The age factor is more important here. So, age is greater than 40 or age is old and credit rating is fair, Bayes computer is yes. So that is this part. Okay, this branch. Okay, so what I want to tell you is, so each branch, we had seen how many branches? 1, 2, 3, 4, 5 branches. 5 branches in this particular decision tree. So each branch from the root to the leaf in the decision tree is being translated as a rule. Okay, so the branch that leads to the leaf node with the let's say the smallest misclassification rate or the least error. Okay, so that could be chosen as the best rule. Okay, some metrics could be kept. Okay, so in this way a set of rules can be learned simultaneously from the tree. Okay, so the leaf node will always contain the the class to be predicted. Okay, so the class predicted, the predicted class label, you would have remembered. When we discussed the decision tree, we had discussed all those aspects. Okay, so I said a set of rules. You can see here a set of rules are being learned simultaneously from the tree. Okay, so this is called simultaneous covering algorithm. Simultaneous covering algorithm. Okay, so if you see here, it was divided into two. A direct method is sequential covering algorithm, and indirect method or decision tree, it is called simultaneous covering. Simultaneous covering algorithm. Okay, so that's regarding rule extraction from decision tree. Okay, so yeah, rules are easier to understand than large trees. Of course, one rule is created for each path from the root to the leaf. You can just read through whatever is being mentioned here in the slide. So each attribute value pair holds a path. Path forms a conjunction. The leaf holds the class prediction. The leaf. Okay, the class prediction is either yes or no. Okay, rules are mutually exclusive and exhaustive. Okay, they cannot occur at the same time. Okay, they cannot occur at the same time. Okay, if they are mutually exclusive, then if they cannot occur at the same time. Okay, so these are the rules which are being extracted. Okay, so now coming to the sequential covering method. The sequential covering method, this is the direct method. Are you all listening? Sharon? Sharon listening? Yes, Sharon. Adya?
Yes, ma'am.
Listening, huh? Oh,
Yes, ma'am.
okay. 63 is responding. Okay. Who's at 63? Sharon. Yes, ma'am. Okay. I hope all of you are making a note of certain things too. Please, dedicate one part of your notebook for writing the headings at least. I'm not asking you to take a big notebook and start writing notes or anything. At least one part of the notebook with all the headings being written, the problems being done. Hope all of you are doing that. I should ask for submission one day to see what happens. Okay, so now coming to the next method called the sequential covering method. Okay, so this actually, you can see here, it extracts rules directly from the training data. Okay, so it is generating rules without generating a decision tree. Okay, so in this particular technique or in this particular algorithm, set of rules is sequentially generated. Okay, so that is one rule at a time. That's why we call it a sequential, not simultaneous. Okay, so one rule at a time, where each rule will cover a subset of positive instances from the training data set. Okay, so Yeah, these are the typical algorithms, sequential covering algorithms. You have your FOIL, AQ, CN2, repair. We will be looking into only the general sequential covering algorithm, what it is. Okay, so rules are learned sequentially for each class. Okay, for each class CI, each rules are learned sequentially. Each for a given class CI will cover many tuples of CI, but none of the tuples of other classes. Okay, that's what I meant to say. Okay, so one rule at a time, where each rule will cover a subset of the instance, the positive instances from the training data set. Okay, so the instances that are covered by the rule for the target class in one stretch, that will be eliminated in the next step. In one step, if it is being covered, it will be eliminated in the next step of learning. Okay, so this algorithm will proceed by repeatedly eliminating the subset of instances what are being covered by the best rule at each stage or at each level or at each step. Okay, so that's how it proceeds. Okay, rules are learned one at a time. Okay, so each time a rule is learned, the tuples covered by the rules are eliminated or removed. Okay, that's what I said. It will repeatedly eliminate the subset of instances which is covered by the best rule for a class at each step or at each stage. Okay, so you repeat the process on the remaining tuples, that is records, until the termination criterion is being reached. That is, when there are no more training examples or when the quality of the rule returned is below a certain user specified threshold or so. Okay, so that's how the sequential covering algorithm works. Okay, one rule at a time. Rules are learned one rule at a time or one class at a time. Okay, so uh, uh, yeah, so a subset of rules, substance of subset of positive instances will be taken in one particular step, so that will be eliminated in the next step. That way it will keep on incrementally proceed. It will proceed incrementally, and then the best rule for the class at each stage would be eliminated in the next stage as far as the sequential covering method is concerned. Okay, so that's what these are the steps involved. Okay, so yeah, here the algorithm is given. So you have the training data set, the rule set, which is a set of if then rules. Okay, so you initialize the rule set. This is the initialized rule set. Initially it will be empty. This is the updated data set. So for each target class CI, repeat the following steps until the updated data set contains the instance of class CI. Okay, so you learn one rule, RI, that correctly classifies some instances in U belonging to the target class CI. Okay, so eliminate instances covered by the rule RI from U and add RI to the rule set. Okay, so that this gets populated. Okay, which was initially empty. Okay, so you can see here. Okay, so while enough target tuples left, generate a rule, remove positive target tuples satisfying this particular rule. Okay, so that's what. What I said is it will learn for only one class at a time. Okay, so when uh, I mean, when learning a rule from class, let's say CI, so we want the rule to cover all the tuples from class CI only, and not any other tuple from any other class. Okay, so you can see here examples covered by rule 1, rule 2, rule 3, all the positive ones, the positive examples. Okay, so each rule will cover a subset of the positive instances from the training data set. Okay, so whatever is being considered in one step, that will be eliminated in the next step. Okay, so the algorithm will proceed by repeatedly eliminating the subset of instance, that is all the positive examples covered by the best rule for each class at each stage. Okay, so that's how it proceeds. Okay, so now coming to the rule generation. Okay, so to generate a rule, it says while true, find the best predicate P. Okay, so you have something coming up here. If FOIL gain of P is greater than threshold, then add P to the current rule. Otherwise, break. Okay, so you can see here something of FOIL gain. There's something called a FOIL gain coming up here. Okay, so this is actually a rule quality measure. Okay, rule quality measure foils information gain, foil gain and foil pruning. So you can see here foil gain. Foil gain is nothing but foils information gain. What the concept of information gain we have already learned. Maximizing the information gain or minimizing the entropy and other things. Okay, so assessing the information gain by extending the condition. So this is the formula which is being put forth for foil gain. Okay, so keep in mind it's a rule quality measure. Okay, FOIL's information gain. Okay, so FOIL stands for, I think it's first order some inference logic or something. You can look into what is the full form for FOIL. Okay, so FOIL ripper and all those things assesses the information gain by extending the condition. Okay, so it favors the rules that have high accuracy and covers many positive tuples. Okay, so that's what is maximizing the FOIL gain. And then you try to rule based pruning based on independent set of tuples. Okay, so FOIL prune metric, FOIL prune metric. So this is another metric, rule quality measure. These are the two rule quality measures. We have the FOIL gain and the FOIL prune. FOIL prune. Okay, so FOIL prune, the formula is being given here: positive minus negative divided by positive plus negative. Okay, so that is actually the number of positive or negative tuples which are being covered by the rule, POS and NEG. Okay, so if FOIL prune is higher for the pruned version of R, then that case you will have to remove that particular rule. Okay, so yeah, that's what FOIL pruning is all about. Okay, so sometimes the rule, so when it is being used, it may perform well on the training data, but then it may not perform that much well or that much good on the subsequent data. Okay, so that's the reason why rule pruning is required. Okay, so yeah, as mentioned here. Okay, so if the pruned version of the rule is having a higher quality than what was assessed on the independent set of tuples, okay, then that particular thing can be, the original one can be removed. Okay, so that's what your pruning is about. Okay, so if FOIL prune is higher for the pruned version, then prune the original rule. Okay, so that's what. So I mean, this FOIL is actually one of the most FOIL gain and FOIL prune. Okay, so it's one of the most simple and effective methods for rule pruning. Okay, rule pruning. Okay, so that's regarding how to learn from the rule. Okay, so that's regarding your rule-based classification. Rule-based classification. So next we need to move on to the model evaluation and selection. Model evaluation and selection techniques. Are you all following the rule-based classification? Did you follow? Sridevi? Sridevi? No response. Jayesh Kumar?
Yes, ma'am.
You're deafening my ears. Okay. Are you listening in class?
Yes, ma'am.
Karthik Balaji? I'm calling out few names whom I know. Karthik Balaji is not listening. Okay, what about my friend Rakesh? Rakesh is there in class today? Or he will come only at the time of attendance? Karthik Balaji is yes, ma'am. Okay. Sridevi is also yes, ma'am. Okay, at least people are responding. That's enough for me. Okay, then what about my friend Rakesh? Rakesh is there today? Anirudh? Yes, Anirudh? Yes, ma'am. Okay. Anirudh is there in class. What about Rakesh? Anirudh is listening. Okay. Rakesh, how does he correctly come come at the time of attendance? I don't have a fixed time to take attendance, but correctly he comes at the time of attendance. So there's some friend in the class who will immediately inform Rakesh to join at the time of taking attendance. Is it? Who is Rakesh friend? There will not be any response for it. No, ma'am. I mean, you are telling you are not a friend to Rakesh, or he doesn't do that. He's there physically in the class. Huh? Okay, let me come back. All are sincere. Oh, my. Anirudh is supporting his class too much. All are very sincere. No, ma'am, listening, ma'am. I doubt, Anirudh, how many are sincere and how many are listening. Now itself, when I call out names, hardly I get a response. When you start coming physically to class, then I will understand how many are sincere, how many are listening. Correct, no, Rakesh? Sharan Varghese, what I'm telling is correct or not?
No comments, ma'am.
No comments, sir. They'll bash you, I suppose. If you support me. Okay, fine. Let's move on to the next. Or shall we take attendance? No. If I take attendance, you will stop listening in the class. Okay, we'll proceed and I'll take attendance at the end today. Okay, then let's move on to the next topic. In fact, the last topic of this unit. But I think we'll require 1 or 2 classes to complete that. The last one is about model evaluation and selection. Okay, so we were all discussing about model building so far. Okay, so now how do we evaluate the model, or how do we select the model? Because model evaluation or model selection, those are all very important part of what is called the model development process. Model development process, it's an important part of your model development. Okay, so it'll I mean, these sort of techniques will help you to find which is the best model that will represent your data, and how well that particular model which we have chosen will work in future. That is for a prediction when a new data comes, or when a new test data is being provided to it. Okay, so that will definitely help us to give an indication or information regarding all these things. Okay, so when you say model evaluation, so model evaluating the model's performance with all the data whatever is being used for training the model. Okay, so that is not a good practice. Okay, so that is actually not being acceptable, be it data mining or in data science, because I mean, evaluating the model's performance just based on the data, training data, is not good. Why we say that is because it can easily generate issues like overfitting the model, or you can say over optimistic model. Overfitting we have discussed, right? When discussing about the decision tree, we had discussed about overfitting. What is overfitting, what has to be done, how to be dealt with, pre-pruning, post pruning, all those aspects we had discussed or looked into. Okay, so it is not enough to evaluate the performance of the model with just the training data. Okay, so when we say model evaluation, like we had learned about both classification models and then regression models. Regression models. Okay, so CART itself is about classification and regression, classification tree and regression tree. Okay, so we need to look into the how to evaluate the classification model separately, and then how to evaluate your regression model separately. Okay, how to evaluate these two separately. Okay, so here the methods, whatever is being mentioned here in the slide, these are all methods for estimating the classifiers accuracy, classification models accuracy, the techniques. These are the things which we will be discussing as a part of a syllabus. Okay, so we have techniques like what is called holdout method, random sampling or random subsampling, cross validation, bootstrapping, and various other aspects. This is about comparing the classifiers. So these are the methods which we will be looking into. Okay, so methods for evaluating the classifiers accuracy. Okay, so today we will look into, how much time do we have? 10 minutes. Okay, we'll look into the 1 or 2 techniques today. Okay, so we will look into what the holdout method is about. Holdout method. Has anybody heard about this holdout method? What is holdout? Anybody has worked in machine learning or done a course in machine learning? What is holdout about? As such, I don't get an answer. Then if I ask about holdout, where will I get an answer? Correct, right? Sharon? Okay, fine. So holdout method. Okay, so holdout means you can see here in the slide. So the given data is being randomly partitioned into two independent set. One is what is called the training set, and the second one is what is called the test set. In the sense, you split your data set into training set and testing set. Okay, so the training set is what the model is going to be trained on. Okay, and when you say the test set, it is used to see how well the model performs on new data or unseen data for testing. Okay, so generally for this holdout method, the common rule of thumb, how you make a split is training data will be 80%. 80% of the data will be used used for training, and the remaining 20% of the data will be used for testing. Okay, this is no hard and fast rule. This is just a rule of thumb which says 80% of the data will be used for training and 20% will be used for testing. Okay, so yeah, training set is 2/3 for the model construction, and testing is 1/3 for accuracy estimation. Okay, so this is another way. Okay, or yeah, there are certain cases wherein you need to divide it into, one can be the training set. Training set, then you have what is called the validation set. Validation set, and the third one is what is called the test set. Okay, training, validation, and test set. Okay, but then not all the algorithms might require a validation set. So a training set means, whatever is used for building the predictive models, that is basically the training set. In the subset of the data, whatever is being used for developing your building your predictive models, that's what is your training data set. Okay, so validation set means, again, that is again a subset of the original data set, which is used to assess the performance of the model which is being built in the training phase. Okay, so it will provide a test platform for fine tuning your model's performance, and then for selecting the best model. Okay, but then all the modeling algorithms don't need a validation set. Okay, then you have the third one, what is called the so-called test set. Okay, where it is basically for accuracy estimation. Okay, so like unseen data or unseen examples. Okay, which is again a subset of the data set, is used to assess the future performance of the model. Okay, so if a model fit to the training set much better than its fit to the test set, okay, then you can say it could be a case of the so-called what is called an overfitting. So those are the things. So that's what your holdout method is all about. Holdout method. Okay, dividing the data into training, test, or into training, validation, and test, depending upon your technique under consideration. Okay, so that's a holdout method. Then we have what is called a cross validation. K-fold cross validation. You can see cross validation. So what is this cross validation all about? Okay, so in cross validation, what you do is you are randomly splitting the data into k folds or k groups. You can see here it is being split into k groups. Okay, so when you split the data into k group, okay, one of the group is used as the test set, and the others will be used as the training set. Okay, so the model is being trained on the training set, and it will be tested or scored on the test set. Okay, so that process will be repeated until each unique group has been used as the test set, an iterative process. Okay, considered to be more effective. Okay, so you can see here a five-fold 5 splits are there: split 1, split 2, and again 5 folds. Each split there are 5 folds. K fold out here, the K is 5 folds. Okay, so the data set would be split into 5 groups, you can say 5 groups. Okay, and the model will be trained and tested separately 5 times. So each group will get a chance to be to act as a test data. Okay, so that's what your cross validation is all about. Okay, so especially when you have a limited amount of data and you want to have an unbiased estimate regarding the performance. Okay, so in such case, better than the holdout method, we go for what is called a cross validation. Okay, so basically you divide the data into K mutually exclusive subsets of equal size, approximately equal size. Okay, so then we build the model K times. Then each time leaving out the one of the subset from the training, and the remaining will be used as the test set. Okay, so that's what your cross validation is all about. Okay, so then there is something called stratified cross validation. Okay, so I think there's 3 more minutes to wind up. So you do have a class after that, right? So let me take the attendance. So stratified cross validation, to tell that, first I have to tell you what is stratified sampling, dividing it into stratas and other things, and then why do we use, what is the so-called stratified cross validation. So maybe that we'll take it up in the next class. Okay, so these are the 2 evaluation strategies or techniques that we have looked into today for evaluating your classifiers accuracy. Similarly, your regression accuracy also, there are many techniques for it, so that we'll look into later. Okay, so that's what we will wind up for the day. Any doubts you can ask me, otherwise you please answer your attendance. Are these interesting things or boring?
Oh, really interesting one, very interesting.
Okay, at least somebody is responding. Fine. So answer your attendance. Anirudh is present. Dharini.
Present, ma'am.
Ramharini.
Present, ma'am.
1 second. Let me reduce the volume. Let me stop the recording too.